Well, welcome to the Physics Chapter 20B homework review, numbers 44 to 51. I had more trouble with this homework. I ended up doing too much of it. Anyway, but I think I've got it all for you. I'm going to do something a little different than what we've done before. I'm going to give you all of the answers, and I'm going to pause, and you could pause the video if you need to. Check your answers. Find out how many of them you got correct before we go through and I talk about how to do each one. Check your answers right now. If this wasn't long enough, pause the video. I'm going to go to the next slide. The variables aren't the most important thing, but the units are very important. Variables are somewhat important. The subscripts aren't as important. Again, if you need to pause the video, do that. I'm going to go to the next slide, though. Okay. And again, you need to pause the video so you can check the answers. Go ahead. When you're finished, count up how many you got right and text me that number. There were 23 total with all the parts. Text me and tell me how many you got right on your own before you went through the rest of the video. And then I will go through the rest of this and show you the work. These are all of like I'm not doing it step by step like I usually do, but we'll go through this. For number 44, they give you two resistors and they want to know what it looks like in series. For a series resistor circuit, you just simply add the resistors. So 1.5 times 10 to the third plus 1.5 times 10 to the third is 3 times 10 to the third ohms. The unit got down to the next line, but there's your answer. If it's parallel, however, it's 1 over R equals 1 over R1 plus 1 over R2. So you add those together and you get 0.0031 and take the reciprocal of that because that answer, 0.0031, is 1 over R. Take the reciprocal and you get 750 ohms. Okay, so the one way you get 3,000 ohms and the other way you get 750. Okay, 45, they ask you to find the resistance of the circuit segment. So the first part of it, you're going to want to do the parallel part. So we have two 6 ohm resistors. For a parallel, 1 over R equals 1 over R1 plus 1 over R2. 1/6 plus 1/6 is 1/3. And the reciprocal of that is 3. So that resistor is 3. And then now you have two series resistors, a 7 and a 3, and that adds up to 10. Okay? Series, you add them together. Parallel, you add the reciprocals. All right. Number 46, they give us the two resistors, they give us the voltage, and they want us to find the current. So the first thing we have to do is to find the equivalent resistance of that circuit. And so, because we're trying to find the current going through the whole circuit. So we do the reciprocals again. We add the reciprocals of the resistors because they're parallel, which gives us 0.1. Reciprocal of that to get the actual resistance is 10. And then Ohm's law, V equals IR. Here we have I equals V over R. It's a rearrangement of Ohm's law. 10 divided by 10 is 1. So 1 amp is the current. Okay, 47. They want to know what the current is in the lower branch. And just remember the total current splits into two parts. So we had 3 going in, 1 goes to the upper branch, and the other one goes to the lower branch, which would be 2. 3 minus 1 is 2. The math on that is not challenging, just knowing what we're looking at. And just think about the context of this. Okay, this is how many electrons are flowing. There are a certain number of electrons flowing into the node. They either go left or they go right, upper branch or lower branch. So therefore, they have to add up to the total. Okay, number 48. What is the voltage? And you have a series circuit like this. Well, the total voltage is just the 3 voltages added together because the battery pushes it up and then it goes down across each of the resistors. And so the total voltage drop has to be equal to what the battery is producing. So 5 plus 2 plus 3 is 10. Okay, 49A. Find the equivalent resistance of the circuit below. Well, that's just adding them together because it's a series circuit, so you simply add them all together. So you get 10 plus 20 plus 10, which is a 40 ohm equivalent resistance for the entire circuit. To find the voltage drop, use V equals IR, and we know the current is 1/10 of an amp, and the resistor is a 10 ohm resistor, so that's 1 volt. The second one is 20 ohms, so you get 2 volts. Voltage equals current times resistance. Again, Ohm's law. The third one is the same as the second, as the first one, 1 volt. Again, 0.1 times 10 is 1. Now the total current of the circuit is just total voltage of the circuit is simply adding those 3 voltages together because that's the whole circuit. The battery puts a certain amount of voltage into the system, electric potential, and certainly you lose that potential as you go through the circuit. So 1 plus 2 plus 1 is 4 volts. That's a 4-volt battery. Okay, 50. They give us some information about the circuit. I hope you're looking at your book while I'm doing this because I'm not recreating all of the stuff in the book. I didn't need to do that. What is the current through R1? Well, we're told that the voltage drop across R1 is 2 volts and that the current, or the resistance of it, is 20 ohms. So I equals V divided by R. Okay, so that's 22 divided by 20, and that gives us 0.1 for the current. Now because it's a series circuit, and so the current through all of the resistors is going to be the same. It's just one path. All the electrons go through the same path, so the same current through the whole thing. So that's the same. Then the voltage drop across R2 is current times resistance, the 1/10 of an amp current through the whole system. A 30 ohm resistor gives us 3 volts. Now, they gave us that the battery, the V is 6 volts. That's the battery, or the external. That's how much is being put into the system. So I was basically just reading the problem. So then they want to know what the voltage is across R3. Well, we know the battery is 6, and we found a 2 and a 3 voltage drop across the other 2 resistors, which leaves 1 volt for the last resistor. Because again, the battery pumps it up, gives it a certain amount of potential, and then it loses that potential through each resistor, each component. And so the only one left is 3, and that's just 1 volt then. And so the resistance of 3 must be R equals V divided by I, 1 divided by 0.1, which gives you 10 ohms. Once again, the math is fairly straightforward. It's just knowing what to put with the math. It really aren't that hard in some ways. I hope I'm not oversimplifying this, but so there we go. All right, so 51A. Find the equivalent resistance of the circuit. It's a parallel circuit, so we do the reciprocals, 1/30th and 1/60th, which gives 1/20th. That's the reciprocal of the resistance. That means the resistance is 20. Find my place. What's the total current through the circuit? I equals V divided by R. The voltage of the circuit is 6 volts. The resistance of the circuit is 20. We just found that. Gives us 0.3 amps. So the voltage drop is just it's 6 volts. Okay, this is what I need to talk about a little bit. Okay, the voltage drop. The only thing that's in there is the resistors. It either goes through 1 or 2, but that's the only component in the system. And so both of them have a 6 volt drop. It has to be the full voltage of the circuit, which is 6 volts, because they are the whole circuit. There's no other component. And the electrons will either drop down the one side or drop down the other side. In either case, they've got to drop 6 volts. Okay? So those were just a matter, again, basically of understanding the problem. In a parallel circuit, the voltage drop across that parallel is the same in both cases. And in this case, that's the whole circuit. So that's 6 volts across that circuit. Okay, what's the current through R1? So the current equals V over R. 6 divided by 30 is 0.2. With the other one, it's 6 divided by 60, which is 0.1. That does add up to 0.3, which we had just found was back in B, that's what we found the current was for the whole system. Remember, with the current, that's how many electrons are flowing. they're being split. So we would expect the two branches to add up to the total, which they do. 2/10 of an amp goes through R1, 1/10 of an amp goes through R2, and those are the two resistors. That's the current then is split. The 0.3 amp current coming in splits two one way and one the other. All right. Well, that's it, folks. We're done. I hope that makes more sense to you now. Hope everything went smoothly going through that. If you do have questions, feel free to text me and I'll try to answer them, or Discord me. We haven't done much on Discord in physics, but feel free to if you need to. Go back and re-listen to the video if you need to. But anyway, thank you all for your work. We got a test coming up here in the near future. I think Tuesday I'm planning the test. So, all right. Talk to you later.